Okay, so this is question 1 from day 4 of the past program for stats, and this is asking you to sketch some normal distribution curves. And there's 2 things that you need to realise for this. One is that when they notate it like this, so x is distributed with a normal distribution, the first number there, which is 30, that is the mean, and the second number, which is 49, that's actually the variance, which is the same as the standard deviation squared. Okay, so there's some old school notation here, but that is how they notate it. So if we go through each distribution we've got, x is going to have a mean of 30 and a standard deviation of 7, because it's the square root of 49. Y is going to have a mean of 30, but a standard deviation of 4, because it's the square root of 16. And Z is going to have a mean of 50 and a standard deviation of 4 as well. Okay, so I'm going to start by sketching out these 2 distributions because they both have the same standard deviation, which is 4, but they have different means. One's centered at 30 and one's centered at 50. What I'm going to use as a rule is the whole idea that with normal distribution, that for 99% it's approximately plus or minus 3 standard deviations either side of the mean. So if I draw myself out an axis, and I go with 30 being there, then for the y distribution, if I go up by 3 standard deviations, that's 3 times 4, so 12. So let's say I go up to 42. Then I would go down to 18, down here. And so I should have pretty much 99% of my curve between there and there. So that's my 3 that way. That's my 3 that way. So it looks something like that. Okay. So that's my first sketch. And then so that's Y in pink. So in blue I'll do Z. So Z has the same shape in that the standard deviation is 4 as well, but it's centered on 50. So if I just put on for myself here what 50 looks like, it's probably up here. Since each of my little scale little things I've used, ticks, is 4, right? So it's standard deviation of 4. So then that should go down to about there, down to about there, which is about 38, and then up there to about 62. Cool. So if I try drawing that, it's going to have the same height as that one there. Okay, so those are my 2 distributions there for Y and for Z. So then when I come to the last one here, which is the distribution for X, it's centered on 30 as well, but its standard deviation is 7, so it's got a wider amount of variation. So I think what a lot of people do when they first see this is they actually they go back to 30 here, and then they just mark off 21 each side and still draw it with the same height. But that's not correct, because with the continuous distribution, like a normal distribution, we're saying that the area under the curve is 1. So this whole area here, if I shaded it, was 1. If I just move it up or down where the mean is but keep the standard deviation the same, we'll have the same shape. But if I make the standard deviation wider, it's kind of like watching an ice cream melt. At first it's quite close together like this, but as it melts and goes further and further away from the centre, your height of the ice cream will also decrease as well, because it's the same amount, it's just being spread over a further width of concrete, let's say, if it's melting on the concrete. So when we draw our distribution for X, which has a mean of 30 but a standard deviation of 7, we're going to have to drop it down in terms of its height. Okay, so we still use the same rule of 3 standard deviations either side. So 3 standard deviations above 30 would be 51, so kind of over there somewhere is where it should be dropping down. And I actually can't draw the other part of it because I didn't make my axes wide enough on here. It sort of goes further down there somewhere. So it's going to look something like this. Okay, so it's still got the normal distribution shape, but its peak is going to be lower, because the standard deviation is nearly twice the size of Y, for example. Okay, and that's how it works.